Good morning, grade 7 students. This is your teacher, Miss Rita. Today we will continue explaining lesson 9, solubility, so please open your books to page 140. Today we will learn how to change the solubilities of solid and gas solutes, and we will solve some exercises. To change the solubility of a solid solute, we can do three things. First, we can stir using a spoon or a spatula. Second, we can heat the solution. And third, we can crush the solid solute to make it smaller particles. Now, of course, stirring and crushing the particles increases the solubility. It makes more solute dissolve faster. Now, let's talk about temperature. For most solid solutes, when the temperature increases, the solubility of the solid solute also increases. And you can see this in your daily life. If you try to dissolve sugar in hot water, it dissolves faster and more than when you try to dissolve it in cold water. Let's try to understand why this happens, why increasing the temperature increases the solubility. You know that when the temperature increases, the particles move faster, which means that the particles of the solute will move faster and they will hit the particles of the solvent more, which means that the solubility will increase. If you look at the picture in front of you, you can see that you have in one beaker cold water and in the second hot water. As you can see, in hot water the solute dissolves more and faster than in cold water. In front of you on your books, you have the following graph. It shows you how different solutes change their solubility with temperature. If you look, you can see that all of the curves for all of the solutes, which are solid, increases when the temperature increases. And this is what we just explained. All of the curves are going up when the temperature increases. Let's look at the solute which is circled in red. It is potassium chlorate. If we look, for example, in front of you, we can read from the graph the solubility at different temperatures. Let's take the example of potassium chlorate at 30 degrees Celsius, which is circled in front of you. If you follow the graph, you can see that the solubility of this solute is 10 grams in 100 grams of water. Now we can take another example. I need you to try to solve it before I give you the answer. I need you to give me the solubility of potassium nitrate, which is KNO3, you can see it in front of you, at 10 degrees Celsius. The answer would be 20 grams in 100 grams of water. Now let's do the last example. Also, I need you to try to solve it in front of you. I need you to give me the temperature now for which sodium nitrate, which is NaNO3, has a solubility of 80 grams in 100 grams of water. The correct answer is 10 degrees Celsius. So since we finished talking about solid solutes, let's talk about gas solutes. Two factors affect their solubility. The first one is temperature, the second one is pressure. When the temperature increases, the solubility of the gas solutes decreases this time. Let's try to understand why. When the temperature increases, the gas particles will gain energy and will be able to escape from the solution, which means that the solubility will decrease. Now, when the pressure on a solution increases, the solubility of the gas solute increases. Let's see why. Because when the pressure increases on the solution, it forces the gas particles to stay in the solution. It pushes them down in order that they stay in the solution and they cannot escape. In these two pictures, you can see the effect of pressure on solubility of gases. In the first picture, you can see that when the pressure increases, more gas molecules or more gas particles are soluble in the solution. If you look at the second picture, you all know that when you open a soda bottle, you can see the bubbles of carbon dioxide that are released and they appear. Why? Because when you open the bottle, you are decreasing the pressure. And when you decrease the pressure, you also decrease the solubility of the gas. In front of you on this graph, you can see decreasing curves. All of the curves are going downward, which means that when the temperature increases, the solubility of these gases decreases. Let's solve an exercise on your books, page 145, number 2. So you have a student, he prepared 3 solutions of copper sulfate, and in each solution he immersed or dropped a copper sulfate crystal, as you can see in the picture in front of you. As given, we have that the maximum mass that can dissolve in 1 liter of water is 320 grams. In part A, we have to determine the solvent and the solute in this solution. So the solvent is distilled water and the solute is copper sulfate. In part B, we have to calculate the solubility of the solution. So to calculate the solubility, we use the equation that we learned, which is that we divide the maximum mass by the volume of the solution. We get 320 grams per liter. In part C, we have to calculate the concentration of Beaker B, which is in the middle. So to calculate the concentration, we divide the mass of the solute by the volume of the solution. We have them as given, so we divide 50 by 0.14 because the volume should be in liters. We get 357.14 grams per liter. In part D, we have to determine the type of solution in each beaker. To do so, we simply have to compare the concentration of the solution to its solubility. In beaker A, the concentration is 250. It is less than the solubility, which means that it is unsaturated. In beaker B, the concentration that we calculated is greater than the solubility, which means that the solution is supersaturated. And in beaker C, we have the concentration equal to the solubility, which means that the solution is saturated. So we have our solutions in beakers A, B, and C. To these solutions, we decide to immerse or add more copper sulfate. We have to explain what happens to the copper sulfate that we added in each beaker. So since beaker A is unsaturated, it means that we can add more solute and the solute will dissolve until the solution becomes saturated. In beaker B, we said that it is supersaturated, which means that if we add more copper sulfate, it will not dissolve, and the copper sulfate that is already dissolved will form crystals, which means that the drop of copper sulfate that we introduced will become bigger. And finally, in beaker C, since the solution is saturated, it means that we cannot add more solute. It will not dissolve, which means that the copper sulfate that we added will stay the same. It will not dissolve and it will not get bigger. Please don't forget to copy the answers on your copybook. Now as homework, study page 144 and solve page 145-146, number 3.